Okay, so what are some things that you recall about inverse functions? Remember anything? Yep. It's reverse. Okay. Anything else? Undos. Okay. Anything else? It's going to reflect across the line y equals x. Okay. And you can switch your x and y, and that'll be the inverse function. Okay. Not Dr. Phil. The concept of inverse functions with exponentials and logs. So on your paper, I would title this inverse function, and then I would say like exponential and logs. So on the left-hand side, we have this equation right here. Okay. So if we wanted to switch this to the inverse function, which we have over here, what we would do is switch our x and y. So looking at this table, we see that we have our x column and our y column. Over here, for the inverse function, we have switched our x and y's. So notice how this column is now the x, and this column is now the y. Okay. So on your paper, I would probably write this equation, write this equation, write the table, write the table. I'll give you a second to do that. So what you're going to do, if you wanted to take this equation and you wanted to make it the inverse, you're first going to switch your x and y. I'm going to put this down at the bottom. You're first going to switch your x and y. You're going to use the circle of life, which I'll go through in just a second. And then solve for your y, which sometimes that's already by itself. Okay, so the 3 steps for how to write the inverse is you switch your x and y, you do the circle of life, and then you solve for your y. Thanks, Mom. So I'm going to show you how to go from this to this. Okay. The first thing that we're going to do is switch our x and y. Remember, f of x is the same thing as saying y. We switch our x and y, and then we do the circle of life. Remember, with the circle of life, you're going to start at your base, go to the outside, finish at your exponent. So I'm going to write this out as log of base 2 of x equals y. And look, it's the same thing as what's over here. Yep, the same. I got a couple of questions on how to do the circle of life. So let's practice this really quick. If I had this function right here, if I had y equals 3 to the x, and I said, find the inverse. Okay. The first thing I'm going to do is switch my x and y. And then now I'm going to use the circle of life. So the way you do that is you start at your base, go to the outside, and finish at your exponent. So this little circle is the order that I'm going to write things down in. So I'm going to say log of base 3 of x equals y. So for those of you who are like more visual learners, if I have something like this, the way I write this out in log form is I say log of the base of y equals the exponent. Okay. I want you to try this one. Write this out in the inverse function. Oop, nope. Let's just make it easy. Let's just make that an x. Write this as an inverse function. So what we're going to do first is we're going to switch our x and y. Okay, so we switch our x and y, and then we do the circle of life. If you just use this thing up here, then that probably didn't work because you got to first switch your x and y. Okay, then that's going to give me log of base 6 of x equals y. And that will be your inverse. Okay, so if I just say, hey, go from exponential to log, that's where you'll use this. If I said find the inverse, that's when you have to switch your x and y. Okay. All right, so we're going to compare and contrast. Yes. So this was finding the inverse. This is just writing it from exponential to log. You'll have to do that as well. Yeah. We're going to skip that. We're going to talk about the key features. So this is the exact same functions that we had earlier. Go ahead and write down for the left-hand side one, the asymptote, the domain, the range, the y-intercept, the x-intercept, and then we're going to fill in the inverse function one. So over here, we can see for our exponential, we would have a horizontal asymptote of 0. That's coming from our equation. And since there's nothing added on that outside, so plus 0, that's going to be our horizontal asymptote. That's where this is coming from. Okay. That's a horizontal asymptote. For domain, for any exponential function, this is always going to be true. For exponential function, so we have an x in the exponent, the domain is going to be all real numbers. That's always going to be the case. Always. Okay. For range, we're going to deal with our horizontal asymptote. And it's either going to be greater than or less than, depending on the equation. But in this case, our range is from 0 to positive infinity. There is always going to be a y-intercept on this one. There may not always be an x-intercept. Okay. Yes, ma'am. I will go through that tomorrow. Yeah. It's on Friday. Yeah. It's gonna be short on Friday. I didn't pick that schedule. I did not pick that schedule. Huh? Block is not on Friday. It's a short one. You complained to your administrators. All right. Ready? We have log, which means that we're going to have a vertical asymptote. Okay, so notice how we had a horizontal for exponential. For log, we're going to have a vertical. And that's going to be at x equals 0. If you look at the graph, right here, there is a vertical asymptote. Okay. You can also see in your equation that it's added nothing inside here. So x plus nothing. So that's going to also be your vertical asymptote. For your domain, this is going to be from your vertical asymptote to either positive or negative infinity, depending on the equation. And for range, it's going to be all real numbers. For exponential, we're going to have a horizontal asymptote. For log, we're going to have a vertical asymptote. Yes, ma'am. Again. For logs. For our y-intercept, it doesn't cross the y-axis, so we're going to put none. And then for our x-intercept, we're going to put 1, 0. What do you notice between these two? Okay. They're switched between these two because they're inverses of each other. So it's increasing the entire time, right? Increasing the entire time. It's not decreasing. We see that. Okay. Now in behavior, remember, in behavior is when you stand at 0, 0 and you look to the right, what's happening to our y values? They're going up. As we look to the left, our y values are going to 0. On the next one, it is also increasing. It's not decreasing. And the behavior kind of flipped. But watch what happened. As x is approaching positive infinity, your y's are also approaching positive infinity. So as we're going over to the right, our y's are going up. And then as x is approaching, this is the weird part, 0 from the right-hand side, your y's are approaching negative infinity. Basically what's happening is between here and here, we're switching these pieces. And that gives you the end behavior for the inverse. Okay. So if I were okay, so if I were to graph this out and fill in the table, remember, we're going to switch our x and y to get the log of base 10. This is your most common used log. So for instance, if you see this log of x, that's the same thing as log of base 10. That's our normal one. The reason why is because think about your number system. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you start it over and then you hit 20. So we have a base 10 system. If you do computer programming, you work normally out of a base 2 system. Okay, so we'll talk about that later. All right, so with that being said, if I graph this, then it's going to look, this is a rough sketch. It's going to look something like this. Okay, I said rough. Okay, and the reason why it's going to look like this is because if you drew the line y equals x runs like this. Okay, this is the line y equals x. If you tilt your head to the sideways, it's going to look it's going to look symmetrical. Okay. All right, if we fill in this table, man, y'all talkative. Okay, if I graph this one, and I could sit here and actually plot all these points if you wanted to, it would just take 5 million years. A lot of effort, not here for it. So if I were to graph this, it's going to be something like 4, -2. It's going to look like this. Again, if we drew a line at y equals x, then it's going to be a reflection across those lines. That you don't see that often, but occasionally you will see. And it probably would be on your SAT, which I know y'all haven't taken that yet, is e to the x. Okay. If I did the inverse function of this, that's going to be log of base e of x. Really quick. For some reason, mathematicians be trifling, and instead of writing log of base e, we now write that as the natural log. So Ln represents log of base e. On your paper, I would write this down. Log of base e is the same thing as Ln of something. These are the same. Okay. Let's talk. So if I have 6 to the x, the way to write that as an inverse is going to be number 10. Okay. 1/3 to the x, if I'm going to write that out, it's going to be 4. So let's talk about this. For number 2, if I was going to do the inverse, I would switch my x and y. And then I would solve for my y. So then I would do the log of 1/3 of x equals y, which is number 4. All right. On number 3, what would be the inverse of this one? 3 and 7. Okay. For number 5, what's going to be the inverse for this one? Okay. And then 6 and then 9. Okay.